I welcome you all to the Spark Research YouTube channel. This is Dr. Virchandra, Assistant Professor in the Department of EC, and this is the very special session on this signal processing course. And this session actually will talk about the some class test related, the questions and answers, right? So this has already been asked in the previous year class test city, right? So first of all, before going ahead, let me tell you total there will be the 4 questions, and each one questions may have the some subdivisions, right? So here question number one is here. So here the question 1A have the four MCQ type of the questions. So question number first is your Laplace transform of the casualty to the power NUT. All of you know that the answer is your the factorial of n divided by s to the power n minus n plus 1, right? Here since t to the power n is there, right? Which of the following statement correctly describe the relationship between the Fourier transform and Laplace transform? Just check it by yourself. Answer is already given here, right? For third question in n-point DFT, the point sequence, what will be the value of the n to avoid the aliasing? So you can check the answer already. And region of convergence ROC of the sequence action is u of n, not this is the n, u of minus of n. So that is why it will be your z less than equal to 1. If it is u of n, it should be z greater than 1, means option A is correct, right? So in this case, this is u of minus n, so option B will be correct, right? So check the properties I have already discussed in the first slide of the unit 3rd. So okay, let's go ahead. Some more question 1b, again it will have the two question 1b. So first question is that system is provided with the second order linear differential equation is there, second order differential equation, some initial values is given y0 and dy0, right? And then asking Laplace transform, nothing else. So simply find out the y of t. So how will you get? So x of t and x of s, like here it is given. So y of s will be nothing, s squared plus 2s plus 2, and how exactly you will get? Okay, let me start from the beginning. So from here you can write this one, that is dy square, and from these equations to write use the same equation, same technique, that is the differentiation d square by d square y divided by dx square. So check the properties. So it will nothing s square ys, then sys, and dy by dt. This part belongs to the this one. Okay. Similarly, 3 dy by dt, you will get 3 ys, sys, and minus of y0. And this is your here 2y into s, and then right side you will get x of s minus x of 0 related to that. Okay. Now put the values, initial values already sys is given here, right? All values are given here. Put it, you will get the value of the y of s, right? Once you will get the y of s, then xt is already given, and right, so xt is here, right? So xt, just take the Laplace transform. So this is the xt, multiply x and y both, you will get the output, right? So y of s is nothing, your the y of s is already given, xt you will multiply, you will get the final output, right? And then you can convert. Actually, after getting this y of s, now you have to come, the finally you have to get the value in the time domain. So use inverse Laplace transform and get the value of the function in the time domain. So finally, before that you have to solve the values of the ABC, and then using the partial fraction you can get the value of y of s by putting the ABC and then convert back into the time domain. So three steps are there. First, we get the value of your transfer function y of s here, multiply with the x of s here, right, y of s only, no need to multiply here. Actually, if you wanted to get the output for a particular input, in that case you have to multiply. So here x of, okay, so here you can get the value of your ys divided by x of s, that is a transfer function, and then multiply, and then get the final value of ys, and then convert back into the y of t, right? So actually measure steps number one, like in if you have the transfer function, the first get the transfer function. So how will you get the transfer function? So h you can get like y by s, y by s. Once if you get the transfer function, then multiply by the input, right, input value, and after multiplying the input value in the frequency domain, again you have to convert into the time domain, then only you will get the time domain output. Okay. Okay, so quickly let's take some more questions. Like here, the question is related to the decimation in time, DIT FFT, fast Fourier transform, right? So here sequence is given, xn is equal to 1, 2, 3, 4, 5, 6, 7, 8, and as it is given n plus 1, n is nothing, 0 for first, for second this is 1, 2, 3, 4, like that. Okay, so you will get this sequence. Now you have to convert this sequence into the DIT. Okay, so how will you convert? So if you remember my the previous to previous like a special, I have already the discussed one special session on DIT and DIF. You can check it. I will drop the link in the description section. So there, what to do here, you have to the first right, like first you have to multiply by the w at 0. Here no need to multiply, here you have to multiply, again no need to multiply, here you have to multiply, no need to multiply, no, yes, 1 1 1 no, yes. Similarly now 2 no, 2 yes, so no, no. Now here yes and yes, again no, no, again yes, yes. Now 4 no, 4 yes, 4 no, 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 here also no, and here yes, yes, and yes, and yes. So how will you multiply? Like the here in this case you have to multiply w0 w8 0 w0, so 1 only. Okay, here w0 w8 1, again w0 w8 2. Here we will multiply w0 w8 1 w8 2 w8 3, right? So and further how will you solve? Further the inputs already we got 1 2 3 4 5 6 7 8, so just put it here and beat reversal output will be there, right? So here actually we are putting the beat reversal values. And what is this beat reversal? Check my special session on DIT DFT, and here you will get the serial wise output. How will you get the output? So input will go serially like that, and here the inputs will multiply with w0, then will go it here. So here the addition of the inputs coming from this side and coming from this side. Okay, similarly here what will be the output? So stage 1 you will whatever the coming you have to multiply -1 you will get, and then here also, right? So here actually you have to also multiply the minus of 1. Similarly here also -1 everywhere, right? Whenever you are going up, just after to that you have to multiply minus of 1, right? So in this way you will get the step output at these steps, like first step. Similarly you have to repeat for second step and third step, you will get the final output. More discussions you can check the special session, right? So I'm going ahead. Finally you will have the answer, right? You have to arrange these values. No need to arrange, already arranged. Here we have to take the inputs from the bit reversal values. Okay, some more questions here. Periodic waveform is given. Waveform is given. You have to find out the Laplace transform. That's all. So this is a waveform. Now write these equations in the time domain. Here we have the same things. Waveform in the time domain. After writing in the time domain, you have to convert into the S domain. How will you convert? So multiply e to the power minus st and integrate e to the power minus infinity to infinity. That's also in 0 to t time period is only in between 0 to t. So multiply and integrate. So only one line integration. Okay, nothing else. So just integrate it. You will get the Laplace transform of your function, this one. So this is the final answer. Okay, let's check fastly some more questions. So here Laplace transform is given, and what to do here? Here like centers SK the same. So you have using your understanding of the Laplace domain for properties, how would you find out the signal looks like at the starting point? Means we have to find out the XFT, right? So how will you get the how will you get the values? How will you find out the signal look like? So the starting means at the x of 0, and settling means after very long time. So initial values and final values. So we have to find, right? So first of all, remember while you are getting trying to find the initial values means s tends to infinity, right? So just reverse. For initial values, use s tends to infinity, and for final value, use s tends to 0. Right? Remember these two things. And then how will you make it independent from s? So just the same equations. First of all, write like this, and you have to divide it such that 1 by s will come, so that 1 by infinity will be 0. And remaining things, if you will cancel out, you will get x0 is equal to 1. Similarly, now again you have to rewrite the same equations in this manner, so that and this will be s of s, x of s again also here also, and you will get the s at the value of s belongs to the 0, means s tends to 0, you will get the value x infinity is 0. So this is the final value, that is at the settling time, at the settle time. At the starting point means the initial value theorem. So this is right. Okay, quickly let's take some more questions. Given two sequences are given, and we have to perform the convolution using the linear properties. So here the sequence 1. So this is your 1, 2, 3. Just check the amplitude here 1, here 2, here 3, and here also 1, right? And this one h of n. So h of n is your here, right? So this is your h of n, that is minus 1. Sorry, at here like 2, wherever arrow is there means is this is at 0. So what is the amplitude at 0? So 2. So here that is why 2 is there, and just left to that means minus 1. So at the minus 1 the value amplitude is 1, then 1 is amplitude here, and then minus 1 is amplitude h, n is equal to 2. So this is the transfer function h of n, and input is x of n. So output you have to get, that is output will be the the convolution of this and this. So how will you get the convolution? First get the inverse, like h of minus of n. So this is h of minus n, this entire one, right? H of minus n. So just the if it will reverse, like mirror image along that, and then keep on adding, right? So keep on adding means here if we'll get h of minus n, so h of minus of minus 2, is there any terms here minus 2 in the x of n? Nothing, so it will be 0. So at only this term and this one both have the common at h is equal to 0. Here value is 2, here value is how much? 2. So here value is 2, and here value is how much? 1. So 2 into 1, okay, and plus here value at 1 is 1, and here value is 3. So 2, yes, so 1 into 2, so total 4, right? Other things not common, right? Left side no 0, in left side no common, and next to the 1, 2, 3 is there, but in this case after 1 there is no value at all, so all remaining things will be 0. Similarly, the shift it by ones, like one's right side, and keep on adding, and after keep on adding you will get the final value like this. Clear? So once if you keep on adding you will get, so here we are shifting once, like 2, 4, 5, like that you are keep on shifting till that you will get the value. So this is a technique to get the convolution. One more question. This is the circular convolution. Check the previous one. Similarly, you can solve it using the circular convolutions also. Now we are moving faster, like use the partial fraction technique to solve it. So just rewrite the equations and get the value something like a by z plus 1, b by z plus 2. And how will you get all these things? You can check the solutions that we have already discussed in the regular sessions, right? In the Laplace transform. Actually same things we have to write like this. So how will you write? So like in such a manner, so that in denominator will be z plus 1, z minus 1 whole square, z minus 1. Why is it so? So that these things are known, like inverse z transform, otherwise we cannot do. Then get the value of ABC. Once you will get the ABC, directly you can convert into the inverse z, inverse Laplace transform, right? Some more questions here. So LTI system is given, input is given. Now we have to find the output. So solve the same equations we have already solved. This is the transfer function in the first question only, and then solve using the the time domain, that is inverse Laplace transform of the same functions, and then further you can multiply by the input so that you will get the output, and then finally you can get, right? Okay, so here the two discrete time sequences represents the output of the digital signal. So x1 and x2 is given. So z transform. Very simple questions. Nothing. Just multiply by z to the power minus of n that functions, that is x of n, and integrate it over. Right. So just this is the for 3z, then 2 z to the power 0, because 2 is arrow is there means z. Right. So 0. So 4, 5 z to the power minus 1, 7 z to the power minus 2, right? And add all this, you will get. Similarly, for this one, your 2 is at 0, so 2 is at 0 means 2. Then 3 is here, so 3z minus 1, and 1 is there, so 1 into z2 minus 2. And 3, you can check 1, 2, 3, so here z to the minus 3 and 8. Okay, so that's all in this season. Thank you to join. If you have any doubts, please drop a comment.